Wearing masks has become part of our new norm, and the demand is high for effective, safe materials and sanitation methods. A Southwest Research Institute team is joining the effort, pivoting from engine emissions to face coverings. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. Hello and welcome to Technology Today. I'm Lisa Benya. Many of us continue to work from home this month, so we are recording this episode by phone. Our guest today is Dr. Imad Khalik, an SwRI engineer and senior program manager. It's really interesting how his team is responding to the COVID-19 pandemic. He leads the Southwest Research Institute Particle Emissions Laboratory. It is the only facility fully accredited by the American Association for Laboratory Accreditation to calibrate equipment to ISO 17025 standards. We'll explain what that means in a moment. Now, this lab usually focuses on engine emissions. Now they are shifting gears and testing mask materials to make sure they are safe and effective for healthcare workers and eventually for the general public. Thank you for speaking with us today, Imad. So, Imad, we hear so much these days about businesses pivoting, manufacturing new items to respond to the pandemic, and some of them even expanding services to meet the needs that COVID-19 has created. And your particle lab is doing the same thing. Tell us how your team is shifting gears to test masks.
Yes, we started this about 8 weeks ago, and the COVID-19 pandemic that led to a massive shortage in masks in the United States have enticed many organizations and individuals to start making their own masks. One of the challenges is to ensure good filtration efficiency and flow resistance of these masks. We felt that we have the capability and knowledge to help in this area and start offering our services in these two key areas.
Okay, so you mentioned particle filtration and flow resistance. Can you explain those terms for us?
Yes. When you design a mask, it's very critical that this mask is highly protective against particles that either viruses are riding on them or they are bioaerosol. So in order to have a good mask, you need to ensure that mask filters these particles properly to protect you when you are wearing them. In addition to that, you need to be able to breathe through that mask, inhalation or exhalation. Otherwise, it will make it difficult for breathing. So there is also a criteria on what's called flow resistance or pressure drop to ensure that the mask that you wear you can breathe through.
So two parts to testing these masks. One, that they can block out particles, and two, that these materials still allow the user to breathe properly. So your lab was testing for engine emissions, and now you've shifted to these mask materials. So how did this pivot come about?
Yes, it wasn't an easy transition. We had to do a new experimental setup, and we had to read quite a bit about mask testing and the requirement needed to be accomplished in the laboratory in order to do a proper work in this area. Because this is a public health issue, it's very critical to get the data right and the number right. Otherwise, you will be giving a wrong filtration efficiency or inaccurate pressure drop, and this can actually have a crucial consequences on those who would be eventually wearing those masks.
Right. When health is on the line, you've got to get it right. No room for error. Tell me about your work with engine emissions and how that carried over to testing mask materials.
Yes. So in my focus in engine emissions is on sub 1 micrometer particles that are emitted to the atmosphere. And those go all the way down to nanoparticles as small as 10 nanometer. So even in the engine emission arena, we cover particle emissions in the size range between 10 nanometer and 1,000 nanometer. We have lots of experience in this area in terms of particle mass emissions, and recently there has been particle number emissions based on the number of particles that are inhaled by individuals. These particles are small. They can actually penetrate deep to the lung, and research show that they can enter the bloodstream and can be found in various organs within the body. What's interesting is when you look at an internal combustion engine emission particles, their size or their mean diameter can be on the order of 70 nanometer to 100 nanometer, and that actually can move either down or slightly up. And what's interesting is the COVID-19 virus has a size range that is very similar to combustion sources particles in the 70 nanometer to 120 nanometer size range. So that's actually this is one of the things that we can apply in particle emissions from combustion sources to viruses and to a certain degree bacteria that have similar size range to that of particles emitted from combustion sources.
So who was the first to connect the dots here that the engine emission particles are very similar to the virus particles and that your lab would be able to facilitate and help frontline healthcare workers with mask needs? Who kind of got that ball rolling?
Yes, I have a good colleague of mine from freshman physics, and he works for the U.S. EPA, Environmental Protection Agency, and he was approached about the possibility of being able to test filters or evaluate filters, mask filters. And the first person who thought about is was me. We've known each other, as I mentioned to you, since freshman physics at the University of Minnesota, and then we get connected that way. At the same time, we get requests from our Division 1, the Chemistry and Chemical Engineering Division, that we have some requests from the university health system for also evaluating mask material. And from there, the ball rolls into the process.
So then you're pretty well known for your particle lab capabilities in science circles, I imagine. As I mentioned, this particle lab is the only facility fully accredited by the American Association for Laboratory Accreditation. That's also known as the A2LA, I believe, to calibrate equipment to ISO 17025 standards. So I think it's a good time to go over that. What does that mean?
Yes. So we use if we focus on masks, in order to properly evaluate a filter material, you need to generate particles. Typically, they are all either sodium chloride particles or other particles that we can generate. And those particles need to be within a specific size distribution range. Now, in order to determine their size distribution, you need to use an instrument that measures that size distribution. The instrument that measures the size distribution, this is something that we calibrate according to ISO 17025 standard. What that means is that there is a rigorous process in the calibration and accuracy of that device that is typically not checked by a regular laboratory. There is also an audit process where a party from the A2LA, the American Association for Laboratory Accreditation, come to our facility and rigorously go through the calibration process line by line to ensure that we are absolutely doing the right thing to produce good quality results. In addition to the size distribution measurement, then you need to measure the number of particles that you measure upstream and downstream of filter material. And we also accredited to calibrate these particle counters, and also that ensure that the counters are accurate and non-biased. And the combination of the two will lead to a very high quality results in reporting filtration efficiency, which is very, very important, especially in the public health setting, where you're identifying this mask to be either a good mask or a bad mask, or whether it meets the standard or doesn't meet the standard. And getting that accurately is very important.
Okay, and this accreditation means that you are able to reach this incredibly high level of accuracy.
That's correct.
Yeah. Okay. I want to touch base on who you are working with on this effort. You are testing mask materials, and you are getting requests to test these materials often these days. So who is asking for these services right now?
Yeah, it's been tremendous for the last 8 weeks. We have several organizations that we work with. And I will name actually several of those. We first start working with Whirlpool and Eaton in their decontamination efforts to decontaminate N95 masks using essentially dry heat or humidified steam to decontaminate the mask. And that way, after decontamination, one can use that same mask multiple times without worrying whether or not there are viruses and bacteria on its surfaces, because this decontamination method kills both viruses and bacteria. My understanding is Whirlpool is donating organs for this process, and also they are using our data for FDA clearance on this effort. We've also worked with the San Antonio University Health System, identifying the right mask filter material that perform better than the minimum requirement of an N95 on filtration efficiency and flow resistance. And we were able to identify a one or two filter media combination that fulfill that purpose for University Health System. We have also identified filter media for WellSpan Health in Pennsylvania that resulted in a 99% filtration efficiency and acceptable flow resistance. It is also my understanding that WellSpan is planning to produce over 250,000 masks or more based on the results that we obtain for them. We also work with other companies like Filter System, Air International Thermal System, and also we've worked with Tesla on the potential development of N95 masks. We also tested some filter materials for them to move forward with that process. In addition to that, we've worked with the city of San Antonio for testing KN95 masks. Those are bought from China, and there are a lot of controversy around KN95 masks, whether they meet the standard, they don't meet the standard. So we end up validating those for the city of San Antonio.
So there are definitely a lot of big names and organizations relying on your data. And so it's a couple of things you're doing here. You are making sure that these masks can hold up after really rigorous, intense cleaning methods. And then you're also exploring new materials to see which ones work best. Am I getting that right?
Yes, that's correct.
What have you found as far as materials go? Is there a new material emerging in strength and reliability for frontline workers?
There are the shortage. 3M companies like 3M and Honeywell and others, they've been producing masks for a very long time, and there has been, as you know, tremendous shortage in that process, and this is what triggered hospitals and many health facilities to look for alternatives because it's better to wear something than wearing nothing, essentially. And so in that process, yes, there has been some identification of material. Some of those materials are derived from the air conditioning filtration system that's typically used in residential homes. Some other materials are coming from clothing products and other of that likes. That's been pretty interesting there.
Yeah, there's a lot of I'm sure a lot of interesting results emerging. So here's the part I love about what you're doing. This is essentially a community service. You're not charging these companies and hospitals to do this work, no matter how big they are. So how did you reach the decision to do this pro bono, and why?
Yes, again, 8 weeks ago, with all these requests that start emerging, and that was in the height of the crisis, we felt that providing this work pro bono to the community was a critical part of Southwest Research mission. After all, the mission is really to serve the public interest, and I discussed this with Institute management, and they were extremely supportive of our effort during this time to help.
It was basically just a matter of contributing to the greater good, it sounds like.
Absolutely, yes.
And had the SwRI particle lab ever been used for other types of testing besides engine emissions before?
No, we've been very busy with engine emissions, and there are a lot of development in that arena, and pretty much 99% of the activities that we've been doing in the particle laboratory were targeting engine emission-related activities. So this is the first time where we completely divert resources to be able to test for mask filter material.
So you've shifted gears now. It's been several weeks. Any surprise findings? What have you learned about mask safety since you started exploring this area?
That's an excellent question, actually, and I'm going to probably elaborate on this a little bit. Well, one of the things that people talk about is N95 mask. And what N95 means, besides some other elements, I'm going to focus on two things. One is the filtration efficiency of the mask, and also its flow resistance. An N95 mask means that it will filter out at least 95% of the particles that are coming in with a flow resistance and pressure drop that is easy to breathe through. And so when you look at commercially available masks, one of the surprises that I saw that those are not simply 95% efficient. The masks actually were 99% efficient and 99.5% efficient when it comes to filtration. So they beat really the standard by a long shot, and it's very difficult. This makes it very difficult to match the performance of commercially available masks, especially from the lead suppliers here in the United States. Now, when you dig deeper into the process, this is eliminating a lot of potentially good materials from being called an N95 mask because this stringency in performance. And one of the requirements to test the performance of N95 mask is to test it at a flow rate of 85 liters per minute, essentially mimicking an individual that is breathing or inhaling at 85 liters per minute. Now, when I looked at the subject of inhalation, and I realized that a typical person, or the lung capacity of a typical person is about 0.5 liters. And when a person is at rest, they breathe around 7 to 8 liters per minute. So they breathe way much less than the requirement that those masks were tested at. And even if we assume that the person now is moving and the activities is increasing, that flow rate can go up to 15, 20, 25 liters per minute, but it's not going to reach 85 liters per minute. And in the testing that I performed, a lot of filter material failed the N95 criteria, mainly because of the high flow rate. So one of the things that I start thinking about is instead of having N95 filters across the board, that they would meet the 85 liters per minute. Maybe in order to facilitate a lot of filter materials to be used and protect essentially the health worker, why don't we start having a procedure where, in addition to the 95% efficiency like N95, we call those filters N95-85. 85 means the flow rate. Then we start categorizing them by saying that this particular mask is an N95-60, N95-40, N95-20, and it will be applicable for different, essentially, flow rate. So if you are in a hospital or a nursing home or some other areas, and if the N95-20 is suitable for your application, then you can use it. If the N95-40 is suitable for your application, then also you can use it. And what this does, it opens up the possibility of having a lot of mask material that could be produced in the United States, and it can actually protect the frontliners and the health activities in different capacity, and then you can preserve those very high efficient masks that requires a high flow rate to a specific areas of activities. I think I feel pretty strongly about this. Maybe this may create some controversy or things of that nature, but this is one of the kind of key elements that really I derived and learned from doing this work.
Yeah, really interesting. So you're basically saying we don't have to rule out all these materials. There are plenty of materials that can protect a person's health at a very high level. At this point, they're being ruled out because they don't meet this 85 liters per minute air rate, but we can go lower and still be just as protected. So that's interesting. That's an interesting finding. And how far are you from maybe developing this system? Have you started the process of developing this system?
Well, we definitely have the capability to report on filtration efficiency of mask material at different flow rates, simulating the different breathing rate, whether it's 10, 20, 30, 40, 50, whatever it is, anything 85 or lower, or even 100 or lower. And that can create really a very interesting option for those health authorities that are making the decision on what type of mask is acceptable for their application. It would be good to have this in the marketplace, and we will let the proper people to choose the proper criteria in which way they want to get their mask for their hospital or workers or whatever the masks are needed for.
Okay, so we'll be keeping an eye on this and see what develops. So that's interesting. Okay, so you are really involved now in this process of testing these mask materials. So I want to ask you if you have any tips for our audience for making a safe mask at home. A lot of us have been told to grab a bandana, or we're seeing tutorials online about making masks out of T-shirts. What do you recommend for those of us who don't have access to these materials that hospital workers have access to?
Yeah, I want to make sure that the public doesn't have like a false positive and feeling good about wearing certain things. Bandana, for example, it's better than nothing, but it's not going to protect really an individual from potentially inhaling the virus if they are in an environment where the virus is in the form of a bioaerosol. Typically, as a bioaerosol, their size is small. It will see the bandana as a football field and opening, and it won't even know that there is anything to obstruct it. So it can go through. I think people. Everybody can go to Walmart or H-E-B or Lowe's or Home Depot or buy a filtration for residential use. They can easily cut those, insert it inside the bandana, and use it. It will definitely help. It will definitely provide some level of protection. If you can afford the more expensive filters for your air conditioner at home, you can also cut those, and those even provide you with higher protection. So there are easy ways where each one of us at home can put together a bandana and can cut a filter from an air conditioner filtration system and insert it inside, and definitely that is going to be a tremendous help versus the bandana on its own. So this is kind of my 2 cents tip to the public on that front.
Yeah, well, we trust you. You're the guy to ask about this. You're doing all the testing. So, yeah, because we're hearing so many mixed messages about how we should approach this. And so the bottom line is it's going to work best if you can grab one of those air conditioner filters, cut it to size, and use it, insert it within your face covering. Okay, great to know. So how do you feel about playing a role in keeping people safe during the pandemic, especially our frontline healthcare workers. What are you enjoying about this new role you found?
Well, I mean, this has been incredible. This is really a great honor and privilege to be able to help during this once in a lifetime pandemic. It's unfortunate, but it brings to me and to the team a great satisfaction and excitement that we are able to help and make a difference during this unbelievable time.
Yeah, certainly making a difference for so many out there who need you and need your expertise. So I want to say great work, Imad, to you and your team. I applaud you for seeing this need and really just jumping in to help with these very specialized capabilities. Not just anyone could have responded to this particular need. So thank you, and thank you for joining us today and shedding light on this area. You know, we hear so much about masks right now, and it's just reassuring to know that you're on the case.
Yeah, thank you for interviewing me, and I hope that this would be enjoyable by others. Thank you.
Our segments, Breakthroughs and Ask Us Anything, are on hold for now. We'll be back in our podcast studio as soon as possible. That wraps up this episode of Technology Today. Subscribe to the Technology Today podcast to hear in-depth conversations with the people changing our world and beyond through science, engineering, research, and technology. Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Stay safe, and thanks for listening.